Good morning to all of you. Welcome you guys. Welcome you all. How we are doing everybody? कैसे हो सभी लोग? I think we are live. First of all, do comment करके बोलिए now. Is my audio videos clear to everybody? Do comment करके बोलिए now. Here is the audio videos clear to all of you. Very good morning to all of you. Yes, first of all, a great news to all the aspirants who are preparing seriously for GATE 2027-28 के लिए अनअकैडमी आपके लिए बढ़िया से बढ़िया ऑफर लेकर आया। नाउ दिस अनअकैडमी गेट 2027 का प्रिपरेशन दैट इज जस्ट 8,999 ओनली। द प्राइस इज गोइंग टू हाइक सून। यूटिलाइज दिस अपॉर्चुनिटी बिफोर द प्राइस गोइंग टू हाइक and the offer is valid up to 11th June only, and you can use a code of my personal invite code, that is PV Reddy, and to get the great discounts and great learning experience from the top educators team. Next, Unacademy diagnostics test. So with this you will get to know here where you can stand, where you will stand with this Unacademy's diagnostics test. For गेट 2027 के लिए बढ़िया से बढ़िया ऑफर. Now we are starting a new batches are commencing from the 12th June onwards. So we are starting a new batches digital as well as a EMFT. Right. You can find the top educators team आपको एक साथ मिलेगा. So 12th June onwards हमने नया बैच शुरू किया. So इस 27-28 के लिए. And these are the Unacademy GATE 2026 rankers. You can find all the rankers from Unacademy team ka. So ESC 2025 ka rankers. These are ESC 2025 ka rankers. You can see now here. So we do offer the two subscription. One is a plus subscription. The other one is iconic. Plus में आपको क्या चीज मिलेगा? The top educators classes मिलेगा, live doubts clear होगा, evaluated test series, structured courses, PDF, live test, unlimited access. Iconic में और क्या मिलेगा? Personal coach मिलेगा and physical notes भी आपको मिलेगा. You can start your serious preparation with the Unacademy. So to achieve your dream goals, we are the team of Unacademy are there to guide you how to start your preparation, so how we can achieve your goals. We are there for you. Start seriously to achieve your dream goals. Chalo, last class we have discussed around 160 problems we have completed, right? So we'll continue the next problems, we'll see. Okay. Yes. Take this one. A constant potential difference is applied between the ends of the wire. Okay. If the length of the wire is elongated by 4 times, length is increased by 4 times, then the drift velocity of the electrons is, right. A constant potential difference is applied. So first of all, you tell me now what is the drift velocity? Drift velocity, which is given as what you can say now, I by ANE. I by ANE, drift velocity. I is what, tell me? Current, which I can write it as what, tell me now? V by R. RANE. V is a potential. They are saying a constant potential. the ends of the wire. Here, what are the variable parameters now here? When the wire is stretched, so then length will changes. So I can write it as area also changes. I can write the resistance is given as rho L by A, and this is A N into E. A will get cancelled, so the drift velocity will come to be what? Tell me now here. V by, that is rho L into NE. Rho V is what? Tell me now. Potential difference. See the constant term here. They are saying the V value constant, rho value constant, charge of electron is constant, and the concentration of electrons is also constant. So we can see now here VD proportional to what? Tell me now. 1 by L. VD proportional to 1 by L, isn't it? So from this, what I can try to tell me now? The drift velocity directly proportional to length. If it is directly proportional to length, so from this, what I can say now here? The length L2, which will becomes what? Tell me now, 4 times of L1 they are saying now. So that means the new drift velocity will becomes what? Tell me now, Vd by 4. So this value decreases by Vd by 4. New drift velocity, length and drift velocities are inversely proportional. So it will decreases by 4 times. Next, a wire of aluminium and a wire of germanium are cooled to a temperature of 77. So this they given aluminium and then germanium. Aluminium is a good conductor. Aluminium is a conductor. Conductors will have a positive temperature coefficient of resistance. For conductors, alpha is positive. If for conductors alpha is positive, that means what? Tell me, as the temperature increases, resistance also increases. If the temperature decreases, what happened to resistance now? As a temperature, here they are saying it is a cooled now. Temperature decreases, then resistance also decreases. Next, what else they are saying here? Germanium. Germanium. So germanium is a semiconductor. Germanium is a semiconductor. Now, so germanium semiconductors will have a negative temperature coefficient. So as the temperature is decreases, means resistance value increases. Now see the option now here. Resistance of aluminium is decreases and germanium increases. So option D. Next, the resistance between the points A and C is, A and C. So we can form a bridge shape now. If I form the bridge, so this is A and this is, here we have a C, and this point we are calling it as B, this point is D. Now see the resistance now between A to B, we have a resistance R. Next, A to D also we have a resistance R only. Next, B to D we have a resistance is R. Next, C to B, the resistance R, and D to C also R. Now you can see now here Bridge is balanced now here. So this means this is removed now here. The diagonal element is removed. So that means what I will get now? RAC, which will be RR. So it is 2R, 2R, 2R parallel will becomes what will be now? R. Next one. The resistance between A and B is resistance between A and B. Okay, so they are asking to find the resistance between A and B here. This resistance they are asking to find. Now you can see now here. If you see from this now with respect to A, so this 3 and these 3, which are in series 6. 6 and 6 parallel will become 3. 3 and 3, 6. 6 and 3. So that means RAB, and which is equal to what you tell me now? 3 parallel to 6, and which is equal to what we can see now here? 2 ohms. Isn't it? Now first these two are in series now. How much is value? 6. 6, 6, 3. 3, 3, again 6. 6 and 3 parallel will becomes what? Tell me. 2 will become. Next one. The resistance between A and B. So you can see now first how these two are. Tell me now. These two parallel will becomes what you tell me now? 5. Next, these two are how much now? So this is a 3. Okay, now if I redraw this part of circuit, next here we have this is 5 ohm resistor, and this is B, and this is A, and this value 3, and this value 3, and this value 8, and this value 5. Okay, so what we can do now? Now this is A. Now I'm calling this point is C, and this point I'm calling it as a D. Let's try to form a bridge form. Try to form a bridge form. So this is A, and this is B, and C, and this is D. Now here we have the resistances A to C, which is equal to what you tell me now? 5. A to D, which is equal to 5. And B to C, which is equal to 3. B to D, which is equal to 3. Next, and which is what we can say now? 8. Now you can see this thing here. Bridge is balanced now, tell me. Okay, the bridge is balanced. So then this is the dead element we can remove. 5 plus 3, 8. 8, 8 parallel will come it as what? Tell me now? 4. So this is RAB, which is equal to 4. Next, the equivalent resistance between A and B is 6. Then they are asking to find the value of R is. Yeah, so the short is there between us. So then this one and these two are dead elements now, tell me. So 15 and R1 parallel. So that is what we can say. Coal India Recruitment. So here Raj ek bar. So you can simply search in the Google Coal India notification. Complete notification will come and you will have a go through that one. Complete notification will come. So you all the engineering EC electrical students are eligible for the Coal India. If you are EC and electrical, so you can apply the Coal India. You can check now whether the date is completed or not. When will be the last date? Do check once. So what is this RAB now? Which is equal to 15 into R1 by 15 plus R1. This equivalent they given us what are now 6 they given. 15 R1 by 15 plus R1. So how much will come you see? So 3 2s and 3 5s now. So this value 30 plus 2R1, which is equal to 5R1. So that means 3R1 and which is equal to 30. So this R1 value how much now? 10 ohms. Next, the resistance of each edge of the cube-shaped wire frame as shown in the figure below is R. The resistance between 1 and 7 is, I told you to remember this trick. Okay. So here resistance between the two adjacent nodes, that is R14, which will be equal to 7R by 12. Next 1 to 8, R18 face diagonal, that is given as 9R by 12. Next body diagonal 1 and 7 body diagonal, which is equal to 10R by 12. Do remember this thing. So here adjacent nodes is a 7R by 12, face diagonal 9R by 12, and then body diagonal is what, tell me? 10R by 12, which is equal to 5R by 6. Option A. Next, three unequal resistances are connected in parallel. Two of these resistances are in the ratio 1:2. The equivalent resistance of these three resistors connected in parallel is given as 1. What is the highest value? So what they given you, tell me now here. Three unequal resistances are connected in parallel. Two of these resistances they given. Okay. Okay, so that means R1 by R2, which is given as 1 by 2. The equivalent resistance of the three resistors connected in parallel. Okay, so that is they given as R equivalent. We can say this as 1 by R equivalent. Three resistors now, that is 1 by R1 plus 1 by R2 plus 1 by R3. This value they given as 1. Now they asking to find this value. If no resistance is fractional also. What is the highest resistance value among these three resistances if no resistance is fractional? Yes, try it now here. R1 by R2 given, so we can write it as R2 from this relation. What I can say now, R2 equal to 2R1. R2 equal to R1. So this is 1 by R1 plus 1 by 2 R2 plus 1 by 2 R1, not 2 R1. 1 by 2 R1 plus 1 by R3, which is equal to 1. Difficult here. So we have taken this as 1 by R1, we have taken common. Then it is 1 plus 1 by 2 plus 1 by R3, which is equal to 1. So then this is 3 by 2R1 plus 1 by R3, which is equal to 1. Now what we can do? What we can do now here? Any idea? Tell me. Yes, sir. We need to guessing only to be done. There is no alternative now. Should be non-integer they given. We should try for guessing only. Whichever the possible options, we'll try it. X value, so we'll take it as 2, 3, 4. Like that, we need to check. So what I will get you tell me now? R3 value. So this is 1 by R3 and which is equal to 1 minus 3 by 2R1. So this means R3 equal to 2R1. Okay, 2R1 by 2R1 minus 3. Okay. Now we can see now here some R1 value we can take something. If I assume, let us say R1 is equal to 2 ohms, then R2 value is 4 ohms. Then what about this R3 value? Tell me now. 2 into 2 by, so this is how much now? 2R1 means 4 minus 3, which is equal to this value 4 by 1, which is equal to 4. Yes, this is one option, but nothing is there. But this option not there. So if we have taken, let us say R1 is equal to 3, we have taken. Next R2 value, which will come to be a 6. Next R3 value, how much now? 2 into 3 by, so 6, 6 minus 3, 3. So will come it as 2 will come. Yes, this can be the possible value. So option D can satisfy. Check it now. So this value, the combination is what? Tell me now. 3, 2, 3, 6. Here R3 value how much now? That is 2. 2, 3, 6. Next one. The EMF of a cell of internal resistance 2 ohm measured using voltmeter of resistance is 998. The error in the EMF is ah, mhm. EMF of a cell. So here, for example, mm, voltmeter EMF of a cell of internal resistance to measured. Okay, EMF. So which we have the resistance which is equal to 2 ohms, and this is the EMF E if I call. They connected some voltmeter they connected, and the voltmeter which having some resistance. How much the resistance they given 998 ohms. Okay, if we connect this as voltmeter, let us say if we connect now, ideal voltmeter connected, then V1 will come it as complete EMF if it is ideal. And if it is practical voltmeter we connected, so in this case, how much now? 998 by 2 plus 998 into E. So that means V2, which is equal to 998 by 1000 into E. So they are asking to find the error now. Error, which means what we can say V1 minus V2 by. So here this is we have V1 into 100. So how much will come here? So V1, so this EMF is E minus, so this 998 by 1000 into E by V1, so this E, V1 is equal to E only now. So this is into 100. So how much this value will come here? 1000. So this value 2. Yes, 2 by 1000 into what will be now 100. So this value will come to be a 0.2%. Next, a battery of EMF 8 volts, internal resistance is given 0.5, is being charged by 120 volts DC supply using a series resistance of 15.5 ohms. The terminal voltage of 8 volts battery during charging. We need to find here. A battery of EMF 8 volts, internal resistance is 0.5. Okay. So this is a battery of this voltage, and which is equal to 8 volts. Internal resistance is given. How much they given? So that is 0.5 ohms. Is being charged by 120 volts DC supply. Okay, it is charged by using 120 volts DC supply. It is being charged 120 volts DC supply with some resistance. This is 120 volts. This resistance is given as a 15.5 ohms. The terminal voltage of this much. The terminal voltage of this battery is. So first of all, we can tell me now here how much is current now here. This is charging. Charging taking the energy, absorbing the energy means current has to enter the positive terminal. So how much is I value tell me now? This is 120 minus 8 by, so 16, na? So 16. So how much this value will come here? 112, na? 112 by 16. Okay. So then how much is value of current now here? 112 by 16. So this value 7 amperes. Now this is charging now. So this is charging means it will absorbing the energy. So they ask him to find the terminal voltage, and this is 0.5 ohms. Now here, these are the terminals. Now here, we need to find the terminal voltage. This is positive, negative, and this is VAB if I call. And this current, we got it as 7 amperes. So this voltage, which is equal to 35, that is 3.5 volts. Now, so this current which we have, how much this current is a 7 amperes, and this voltage which is equal to 3.5, 35 ohms, and we need to find this voltage. So we'll come it as VAB, and which is equal to what terminal? 8 plus, so that is 3.5. So we'll come it as VAB, which is equal to 11.5 volts. Next one. If E1 is given 4, E2 given 12, the current in the circuit and the potential, the resistance is missing now. Okay. So then they ask him to find what terminal here. The current in the circuit and the potential difference is. Tell me how much is the current? Now this positive connected negative, so here addition. So this current I is equal to 12 plus 4, 16. 16 by 8, 9, 10. So this is 10 will come. Resistance might be different, I think so. Yes, if I assume this might be something 15 we considered. So then we'll come it as 16 amp. So no 15. So this value, okay, 9, and this is 7 we considered. Tell me now here 7 ohms, then it is 16 and will come now. So we'll come it as 1 ampere. They ask him to find the potential difference. Potential difference, which means this is the voltage across this element only, P and Q. So that it means VPQ, which will be equal to 8 into I, which will be equal to 8 ampere. So that means this is 7 ohms only, correct. So this is the option. Next, two identical cells gave same current through an external resistance of 2 ohms, regardless whether cells grouped in series or in parallel. The internal resistance of the cell is. Two identical cells, they have connected same current, okay, in series or parallel. Yes, this is one source and there is another source. When we connect these two in series, external resistance is given as how much you tell me now, 2 ohms. Yes, this is 2 ohms. This EMF E and this also EMF E, this resistance R if I call. So you tell me now how much this value of current now in this case I1 if I call. So I1 is equal to that is 2E by that is R plus 2. Now the two sources connected in parallel. When these are connected in parallel, to this external resistance of 2, this current if I call this as I2, and this is EMF, this is R, this also is same EMF, this is R. We can convert the voltage source into current source and we can get this currents now. So this means how much this value of this current I can say. So this current, if I call this as I1, this current is I2. So this I2, I is equal to what you can see now, where I is equal to, that is I1 plus I2, that is I, which is equal to what you tell me now, E by R, plus what you tell me now, E by R. Okay, so this is equal to 2E by R, isn't it? Only एक बार check करिए. So let us see here. This voltage source were converted into current source. Then this current, which will come to be what? Tell me now here. This is E by R. The resistance will come in a parallel. Will come now. Okay. Now this is R. And this is E by R. And this is 2 ohm resistor. Okay, now. So these two will be added, will combine now here total current, which will come to be a what? Tell me now. So this is E by R plus E by R, that is 2E by R. And this total resistance, which is what? Tell me now, R by 2. This is what? Tell me now, R by 2, parallel combination, and which is equal to 2. Now again, so this convert into voltage source now. Now this is again converted to voltage source. This is R by 2 and this is E. Now how much this value? Tell me now here. This is 2E by R into what you tell me now, R by 2. 2 cancel R. So this is EMF is E only. And this is 2. Now what is the current here in this case now? I2. I2 equal to what I can say now, E by R by 2 plus 2. So this is what we can say now here, 2E by R plus 4. So the options are not proper. Okay, here this is 2R na, 2R. So these two currents are same, they are saying na here. So they are saying this as I1 equal to I2. Initial, these two currents are equal, they are saying na. I1 is equal to I2. So what is this I1 value? 2E by, that is 2E by, that is 2R plus 2. So green is not visible. Sorry. So here I1 is equal to I2, right? I1 and I2 are equal now here. So that is 2E by 2R plus 2 and which is equal to 2E by R plus 2, isn't it? R plus 4. So this means what I'll get down here, 2R is equal to what you tell me now, R plus 4. That is, R is equal to what we can say now, 2 ohms. Good problem. A cell of EMF 1.2 volts, internal resistance 2 ohms, is connected in parallel to another cell of EMF 1.5, resistance 1. If the like poles of cells are connected together, the EMF of the combination is. Now, so this is thus connected. Green we should not use. So this is two cells having EMF. This is 1.2 volts and resistance is 2 ohms. This is connected to another one. The like poles are connected. There is positive connected to positive, negative connected to negative. This is 1.5 and this is 1 ohm. Yes, they connected like this. The like poles, the whole combination they ask them to find how it will behave. The net EMF. Yes, the net EMF of this combination, which is equal to what we can say now. So this is E1 R1, E1 R2. So E1 R2 plus E2 R1 by R1 plus R2. So we'll come it as what tell me now here, E1 R1 1.2 into 1 plus E2 R2 1.5 into 2 by, so this is 3. So this value will come 1.2 plus 3 by 2, which is equal to 4.2 by 2. What here? No option. Let's try the normal method. So this one, what I can do here, we'll convert into current source now here. When I convert this is a current source, and then resistance will come in a parallel here. So this we can write it as E1 by R1. Next, this is another current source will come. This is E2 by R2. Now here these two resistors are in parallel, which will come to be a what you tell me now here, R1 R2 by R1 plus R2. So these two are added. So this is E1 by R1 plus E2 by R2. Okay. Again apply the source transformation. Then this is positive, negative, and resistance will come here. And this is the net EMF and this is the equivalent resistance. So it will come to be a, what tell me now, net EMF is E1 by R1 plus E2 by R2, yes, into what we can say now, yes, R1 R2 by R1 plus R2. So EMF E. So this is E is equal to, if you take LCM, E1 R2 plus E2 R1 by R1 R2. This is R1 R2 by R1 plus R2. The same thing now we did. R1 R2 will get cancelled. So the EMF will come to be what, tell me now? E1 R2 plus E2 R1 by R1 plus R2. Okay. we derived the formula and we can substitute now here. E is equal to E1 R2. So this is 1.2 into R2 is 1 plus 1.5 into 2 by R1 plus R2 is 3. So this value will come 1.2 plus 3 by 2. So this value 4.2 by 2. So we are getting 2.1 we are getting now. Check now, no option is matching. So any options may be mistake. We'll do the other method. So might be the options may be mistake. And this is 1.2 volts and 2. And this is 1.5. This is 1. So we'll convert it to current source. This current is this direction. How much is current is 0.6 amperes. And this current is how much now? 1.5 amperes. And these two parallel. How much this value tell me now? So here 2 by 3 now. And these two will be added to 0.1. When you add it now here, the total current which we got it as what will be now 2.1 amperes. And the resistance is how much now? 2 by 3. Resistance is 2 by 3. Then this voltage value 2.1 into 2 by 3. This value will become 0.7. So which will come 1.4. 1.4 is there, but why we got wrong answer here in this method? कोई गलत किया क्या हमने चेक करो. E1 by R1. Okay, yeah, this is 3 now. This is 3. This is 4.2. 4.2 by 3. So this value 3 ones, 3 fours. Yes, correct. This is 3. Here, this is simplification mistakes. Correct. Next one. 5 equal resistance each two are connected as shown in the figure. There is current, a battery of V volts connected between A and B. A and B. Then they ask him to find the current through FC. They ask him to find. Yeah, what will do? FP is nothing but A only, isn't it? F and A both are same only. AC we need to get. Okay, if I try to redraw as a, so how many points are, B is nothing but E only, na? Yes, we try to redraw the bridge shape. Yeah, this is A. A is nothing but F only. And this is B. B is nothing but E only. Next we have C and this is D. Yeah, you can see now between A to C means F to C. Resistance, all are equal resistances only. Yes, so this value 2R, this resistance is also 2R, 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 and C to D also resistance. So 5 resistances are placed like this. And this is also 2R. Now, bridge balance now will disconnect this element. Now, where we need the current now? F to C we need the current. They ask him to find the F to C. Hmm. Bridge balance. Bridge balance, So then equivalent resistance is how much now? 4R. So this is 2R. So that is equivalent resistance, which is equal to 2R. Then what will be the current in the branch? You tell me completely, and which is equal to V by 2R. So their current, which I can say this is Ix. And what is Ix value? Tell me now here. I by 2. So that means V by 4R. Sorry. Um, mm, Fine, I'll write. Next one. A straight wire R is bent in the shape of a square. A cell of EMF 12 volts is connected between two adjacent corners of the square. The potential difference across any diagonal of the square is. The potential difference across any diagonal of the square is. And what they're saying here, a cell which is connected like this, a straight wire of resistance R, it is bent in the form of a square. It is, so each resistance is, so each part will have equal resistance now, and this resistance is R by 4, that is R by 4, R by 4, and this is also R by 4. A cell of EMF 12 volts is connected between two adjacent corners of the square. Here they connected. This is 12 volts is connected here. Across any diagonal. So between this point and this point, they are asking to find the potential difference. This voltage we need. Okay. Yeah, you can tell me now here how we can get it now here. First of all, so you can find the equivalent resistance now here 3R by 4. What is the equivalent resistance here? 3R by 4 parallel with what, tell me now? R by 4. And so that is R equivalent, which is equal to, so 3R by 12, 13. And what they're saying here, this is the square, and they connected 12 volts battery, they connected. Each resistance are same only. So this is R by 4, R by 4, R by 4, and this is also R by 4. So 3R by 4 parallel with this thing. So 3. So how much is R equivalent to, tell me now here? So this value 3R by 12 plus 1, 13. This is the equivalent resistance. Now we can get the current now. How much is I value? This is 12 by, so this is 3R by 13. So 3, this is 4 now. So I value, which will come to be a, what you tell me now here? 13 into 4, 52 by R. This thing you got now, tell me first thing. Now here this current is I. Now we can say this current, some current will divide here and this current is divide here. I1 and I2. Yeah, if I get this value of I1, let us say I2 will get directly fine. I2 I am getting it as what, tell me now? R by 4 by, so that is 3R by 4 plus R by 4 into I. I is equal to 52 by R. So will come to be a I2 equal to what you tell me now here? That is R by 4 by R into 52 by R. Now, so this I2 value will come to be what, tell me now? 13. 13 by R na? Now we can write the KVL. So we should get this voltage na? So this is what, tell me now here? So 13 by R into R by 4 plus 13 by 4 into R by 4. Yeah, simplify now here. V is equal to 13. R will get cancelled. R will get cancelled. So this is 13 plus 13. So this is 26 by R 4 now. 26 by 4. So 6 volts. Okay. Next one. In the given circuit, if the potential difference at point B is 24, the potential at point A is, potential at the point B is 24. They are asking to find the potential at the point A is. Yeah, they given this is the positive given. So first we'll find the current here. And what will be the current, you tell me now here? I which is equal to 36 minus 12 by 5. Okay. So I will commit as, what, tell me now here, 24/5 now. Now this potential difference we need to find. This potential difference between these 2 points. So this point which will be given as now. So we have taken this thing, this potential which is equal to, so this one, this potential is given as VA. At this location, this is VA, and here this potential is VB given. This potential is VB, and that is positive ground. Here, this is positive ground. And so this resistance is 3, and this is 24/5, and there is a current. How the current will flow? Like this will flow current. And we will write the KVL in this loop. So what I will get now here, 24/5 plus 3 into I plus VA minus VB equal to 0. This is why 24? Yeah, this is 12 now. This is 12 volts. 12. So 12 plus this is 3 into 24/5 plus VA minus VB. VB value given 24 is given, which is equal to 0. From this, we should get the value of VA. How much will come VA? VA is equal to, this is 12 minus 3 into 24/5. So how much this VA value will come? So 60 minus 24 into 3 into 3, 72/5, which means minus 12/5 na. So this is 12/5, which is 2.4. So VA value is what will be now? Minus 2.4. Minus 2.4. Option. Next one. A current of 6 amperes enters one corner P of an equilateral triangle PQR having 3 wires of resistance 2 ohms each and leaves by the corner R as shown in figure. So the currents I1 and I2 are. So this current, so basically we can say I1 plus I2, and which will be equal to 6 amperes. Now this I1, so this current is also I1 only. Now if we write the KVL in this loop, now tell me, will come it as 2I1 plus 2I1 minus 2I2, which is equal to 0. I2 will get cancelled, 2 will get cancelled. So this is 2I1 equal to I2. Now we can place it now here. So this is I1 plus I2 equal to 2I1 equal to 6. So that is 3I1, which is equal to 6. That is I1 is equal to 2 amperes. Then what about this I2 value? 4 amp. Okay. Next one. A voltmeter of resistance 400 ohms is used to measure the EMF of a cell with an internal resistance 4 ohms. The error in the measurement. I think similar kind of problem we did. A voltmeter of resistance 100 ohms and 400 ohms used to measure the EMF of a cell. Is a cell having some EMF, having the internal resistance is given as a 4, and here the voltmeter is connected. That voltmeter will measure the EMF of the cell. If it is an ideal voltmeter, so EMF should be appears to be what? Tell me now. Voltage measured will be EMF U only. But because this is not an ideal voltmeter, certain drop is there. So how much this value? This is 400 by 404 into E now. They ask him to find the error. So this means error in the measurement. What we can say now, V2 minus V1 by V1 into 100. So that is V2, this is 400 into E by 404 minus E by, so this is E into 100. So this value is what? Tell me now. So this is minus 4 by 404 into 100. So this value how much now? It is minus 1 by 101 into 100. So how much this value will come? This will less than 1 only now. That is 0.99 will come. That minus means decreasing now. That's why it is. Okay. This is 100 by 101. This value 99 like this will come. Next one. When two identical resistances are connected in series to an ideal cell, the current through each resistor is 2 amperes. If the resistors are connected in parallel to the cell, the current through each resistor is, when two identical resistors are connected in series to an ideal cell, what they given now here? Yes, two identical, so connected to the ideal cell, ideal voltage cell, that means resistance is 0, so it has certain voltage when these are connected in series. When these are connected in series, yes, series they connected, so this current is I1 if I say, this resistance is R and R. So this is I1 is equal to V by 2R. This value they given as a 2 amperes. The resistors are connected in parallel now. Now these are connected in parallel. If the two resistors are placed in parallel, so then the scenario is like this now. This resistance R and R. Now what is this current now they are asking to find now here? So this current, if I call this as Ix, this current is Iy. What is this thing? Ix is equal to V by R, and which is equal to 4 amperes. IY, which is also equal to V by R, that is equal to 4 amperes. So this is option. Next one. 3 resistors of resistance 10, 20, 30 are connected as shown in figure. If the points A, B, and C are at 10, 6, and 5 respectively, then the ratio of the magnitude of current through 10 and 30 is. If the points A, B, C are at potential 10, 6, and 5 respectively, then the ratio of the magnitude of currents through 10 and 30 is. So all these points are connected to a same potential now. Let us say this potential, which I'm calling it as a V. Okay, so then at point A, the potential is given as 10. Point B, this is 6. And point C, this is 5. We can write the nodal equations. Now tell me now here, V minus 10 by 5, 10 by 10, plus V minus 6 by 20, plus V minus 5 by 30, and which is equal to 0. So 0 will get cancelled. V we have taken common. This is 1 plus 1 by 2 plus 1 by 3. Yeah, which is equal to what element of 1 plus 6 by 2 is 3, and this is 5 by 3. So this is V, which will come to be what element of 6 is LCM. So 6 plus 3 plus 2, and again here 3 is LCM. Now 3 plus 9 plus 5. 3 2's now here. So V, which will come to be a 11. 11 by 2, which is equal to 8. So this value, how much will come here? So this value 12, 17, 17. So V value will come to be a 34 by 11. They ask him to find the ratio of the currents of 10 and 30. 10 ohm. So this current, which I can say, this current is I1, and this current is, let us say, I2. So you can tell me now here I1, which is equal to 10 minus 34 by 11 by 10, and which is equal to 110 minus 34 by 100. So no, 110. Next, I2 value, how much now? That is 5 minus 34 by 11 by 30. How much this is? 55 by 34 by 33. So this value, how much now? 110 minus 34. How much it is? 76 now. 76 by 110. Now this is 55. So this value 21. 21 by 330. Okay. Now we need to get the ratios now here. This is I1 by I2, which will come to be a 76 by 110, and this is 330. 330 by 21. So let's simplify now here. Yes, so this is 3's. So 3 7's now. What, yeah? Options are not coming proper. कोई गलत किया क्या हमने? चेक करके बोल। एनी मिस्टेक वी डिड? हाँ हाँ। 10, 20, 30. So this voltage is 10, 6, 5 only. So V minus 10 by 10, V minus 6 by 20, V minus 5 by 30 equal to 0. So will come. Any mistake we did, tell me now? कोई कैलकुलेशंस या सिंप्लीफिकेशन मिस्टेक हमने किया क्या? चेक करके बोल। हम्म। हम्म। Now this is nodal equation V minus 10 by 10. Okay. Plus V minus 6 by 20. I think here we did a mistake, I think so. And V minus 6 by 30. V minus 5 by 30. Yeah, V minus 5 by 30. And which is equal to 0. Now you tell me now here. V common. So this is, yeah, V by 10 common. So this is 1 plus. This is 1 by 2 plus 1 by 3. And right side, which is equal to 1 plus this is 6 by 20. And this value 5 by 30. Now here we can write this as 10 by 10 if I write the 0, the 0, the 0 if I cancel it now. V. Now it will come to be a what? Tell me now. So 6 is LCM now. So this is 6 plus 3 plus 2 and which is equal to 60 the LCM. So 6 plus 3. So 18 plus 2, 10. So this 6 and this 6 will get cancelled. V is equal to how much now here? This value 20, 24, 34. Yes, 34 by 11. Same thing we got earlier also now. Then we need to get this I1. I1 is equal to 10 minus V, that is 34 by 11 by 10, which is equal to 110 minus 34 by 110. So how much now? 110 minus 34? 76. 76 by 110. Same thing now we got earlier also. Next I2 value. How much will come here? This is 5 minus 34 by 11 by 30. So how much will come here? 55 minus 34 by 30 will come it as 21 by 30, isn't it? But options are not matching properly. So this is I1 by I2. I1 value 76 by 110. And this is so this 330 by 21. So this is 3 now, 3 sevens. अगर कोई मिस्टेक आइडेंटिफाई किया तो बोलो, इफ आई डिड एनी मिस्टेक. हम्म. 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 क्या हो गया है? समथिंग वी डिड मिस्टेक. Click करो where we did mistake. Values correct only we have taken now. Hmm. So here A value 10 volts, okay, B value 6 volts, and this is 5 volts, and at this location the voltage is V. Now you tell me now once again, V minus 10 by 10, okay, plus V minus 6 by 20, okay, plus V minus 5 by 30 equal to 0. We have taken V value. This is 1 by 10 plus 1 by 20 plus 1 by 30, and which is equal to 10 by 10 plus 6 by 20 plus 5 by 30. Now we have taken LCM, which is equal to 60 is LCM now. So 6 plus 3 plus 2. And here also 60 is LCM now. So I will come it as what, tell me now? 60 plus 3, 18 now, plus this one 3, 2, 10. So this 60 cancelled. So V value how much now here? 11. And this is equal to how much now? 8, 6, 7, 8. 88. So V value which will be equal to 8. Yes, here is a mistake we did. Earlier calculation mistake. Now we'll try to do this thing here. We need this current is I1, this current is I2. So what is I1 value? This current will go here this direction. So I1 is equal to 10 minus 8 by 10, which is equal to 2 by 10. So this is I2 equal to 8 minus 5 by 30, which is equal to 3 by 30, which is equal to 1 by 10. So we'll come this as I1 by I2, that is 2 by 10 into 10 by 1, which will come to be 2 by 1. Yes, correct. So calculation should be very careful. Previously, we mistakenly taken this as 1 we have taken. That is a problem. Okay, fine. Next one. In the circuit, E1, E2, E3 is given. Okay. The current flowing through E2 is. Yes. This value, how much E1 value 2 volts given? R1 is given as 4 and E3 given as what element of 2 and R2 given as what element of 4 and this value 2. So we can convert into current source now here. We'll convert into current source. So this value 1 by 2 current. And we can get this current also. Yes, this current is also 1 by 2. Now 4 and 4 will parallel, will become this value 2. This is 2 volts. We should not disturb it now here. So this value 1 ampere, again source transformation. So it will come to be positive. This will come to be negative. So this is 1 volt and this is 2 ohms. Now this is A and B and this is 2 volts. And you can find this current will go like this now. So this I value, this is 2 minus 1 by 2. Okay, so this value 2, okay, this value 2 volts now. So this current is 0. So this is current is 1 ampere. Again, source transformation 2 volts. So this current is 0. Yeah, right. In the circuit shown, the value of current I is. Now here we'll convert into current. So this is 4 amperes. We'll convert into current so simply. So this current, which is equal to 4 amperes, this direction positive, and then 3 ohms. And here we have 1 ampere, this direction now, and 6 ohms. Now these two we can combine now 5 amperes. These two, this current is this direction. These two parallel will become 2 ohms. Again, source transformation will come it as 10 volts and 2 ohms. And this is positive and this is negative. So which will come to be what, tell me now here. This is 10 and this is 2. This is 4. Now this current I is equal to 10 by 6. So which will be equal to 2 5s, 2 3s. Is 5 by 3. Okay. Well, so 4 amperes, 3. Okay. This is 1 ampere, 6. These two we combine now. This has 5 amperes, 2. And then this is 10 volts, 2. Correct only na 5 by 3. What happened now? Any mistake we did? Here this current. How much is value of current, you tell me now? This current is 4 amperes. Okay, next thereafter this current is how much now? 6 by 6, 1 ampere. Now these two parallel and will come to be a 3 6 parallel. 3 and 6 are parallel, which will come to be a 2 now. 2 and this is 4. Now this is 5. Yes, current which is 5 amperes, and then resistance is 2, and this resistance is as usual. This is 4. Now this value 10, and this will come in series now like this, correct only? So this is 10 volts, and this is 2, and this is 4. So this current I value is equal to 10 by 6 only. Yeah? I think we did correct only. Fine. Okay, yeah, that's it for today, and we'll continue next class.